Hi, I'm Dave Taddeo, and this is Coders Tech. It's Wednesday, September 3rd, 2014, and this is episode 7. Today I'm going to talk a little bit about color and how it pertains to coding. It's my opinion that color is very important when it comes to coding. Whether you're doing ophthalmic lenses or whether you're doing precision optics, it's the first thing we see when we take lenses out of the coding chamber. We look at them, we see the color, we assess whether there was something done wrong or whether they look good, and we can move on to the spectrophotometer to actually measure the performance of the thin film. But color is also very important, especially in ophthalmics, where the AR coating has a particular color, whether it's a little bit green, whether it's a little bit blue. There's also the new digital eye strain coatings that reflect a lot of the blue, and especially with mirrors. It's summertime, everybody's got their sunglasses on, and they want a mirror coating, whether it's green, whether it's blue, maybe violet, whatever the case may be, and that becomes part of fashion as well. So color is very, very important. It's also very important in precision optics where you're doing display technologies, maybe a projector, you need to really define your red, blues, and greens, or whether you're doing screens, LCDs, LEDs, and so on and so forth. So let's take a quick look at what color is. And for that, I'm going to go to Wikipedia. I'm going to share my screen with you, and we'll take a look at Wikipedia. Okay. Here's color in Wikipedia. There's lots of good information here. It's a fairly large document or input into Wikipedia. And it goes into a lot of detail. Physics of color, spectral colors. It gives you the wavelength ranges of the different colors, red, orange, yellow, green, blue, and violet, and so on. A lot of the, like I say, physics of that color and the temperature. This is really, really good. It talks about color in the eye, how we see color. And this is very important as well, especially in ophthalmics, where color is so important. And color is a bit of a fashion statement. So the ophthalmics business runs a little bit on function and a little bit on fashion as well. So this is a very good article on Wikipedia with all the data you need for color. And it's a good way to train employees, staff, technicians, operators, engineers, management, and sales staff on how to go forward and talk about color. Okay? So that's color. We can see red, orange, yellow, green, blue, violet. But just as important is color temperature. And I've got that here, color temperature. And you can see, I'm going to open up this particular image. And you can see these color temperatures in Kelvin. And at the low end here, we've got 1500 and 2000 Kelvin, and 2500 and so on. And here's 5000 right in the center, right where you see it white. Okay? And you'll probably recognize these when you buy light bulbs. And there will be a color temperature on that light bulb. And typically, a regular incandescent bulb, excuse me, is 2800 K. And the new LED bulbs you'll see that are dropping in price nicely, and more people are buying them, are usually around 5000 K. You can buy them at 2800 K, but typically they're around 5000 K. And you can see on this CIE color graph here where 2800 sits. It sits in this yellowish part of the spectrum, and 5000 sits almost right in the center where it's nice and white. Okay, and when you look at that here, this 5000 K is your horizon daylight. Your 2700 or 3300 K is your incandescent lamps. And this is really, really nice article. It shows a comparison of what they look like. You can see this is a little bit orangish or a little bit yellowish. This is getting whiter, and then this 5500K fluorescent lamp is almost bluish. And when we see in this little GIF here, this animation here, how color changes with color temperature. We can see how it changes here. Okay? And one of the reasons I bring that up is very important. Excuse me. In your lab, you have lighting. You have probably fluorescent lighting to light the entire lab. And at the quality control station, you have maybe an incandescent bulb or a single lamp where color is assessed, especially with ophthalmics, color is assessed. And it's very important that if you're looking at a coating with a fluorescent bulb that has, let's say, a color temperature of 3000, the whites, the blues aren't there. So the color of the AR, the reflection of the AR, or the reflection of the mirror is going to be a little bit different. Those blues are not emitted from the lamp itself, from the light source itself. So when you have a 5000 K color temperature bulb, those blues are now there and it will look different. So it's very, very important that when lenses come out of the coating chamber, whether you're doing ophthalmic lenses or whether you're doing precision optics lenses, that there's a central station to observe or to look at or assess color, and especially in quality control. So taking lenses out, stepping aside to a particular station or to a particular place where lighting is standardized is very, very important. Or you could change all the lighting in your entire lab to the exact same lighting, to the exact same color. Either way is good. But light, color, and color temperature are very important in assessing color, especially in ophthalmics. Okay? And so I just want to show here in FilmStar a nice way to assess color in a design while you're putting in a process of, in this example here, a red mirror. And I think it was in episode 2 or 3, I showed the interactor, and I'm going to show that again. So I have here a red mirror example. You can see across the bottom here, the reflection is fairly low. There's a little bit of ripple here. And then it comes up, the reflection comes up quite high at the longer wavelength end of the visible spectrum. So this is our reds, and our reds are being reflected nicely. So if I go into Evaluate and click the interactor, now I can see my spectrum here, and here's what color it is. Down in the bottom there's a little swatch, and if I click Evaluate again and RGB comparator, that's what the color is going to look like when it comes out of the coating chamber. Okay? This is a really nice way to look at coating designs, look at processes before they're even implemented. This way you can really tell what color you're going to get. One quick thing I want to show you about the interactor, which is really nice. I'm going to close this out. I'm going to go back to my red mirror example. I'm going to click on Spectra and Copy Data. Then I'm going back into the interactor, Spectra, and paste that data. And now you can see I have 2 swatches of color down here. They're both the same, but there's 2 swatches of color. When I bring up the RGB comparator, now I've got this full circle. In the center is the design I'm using, and around the outside is the pasted data from the design, from the page prior to this. Now if I go over here to the interactor section of this, I'm going to select all. Just for this quick example, I'm going to select all these layers here. You can see that they're all going to change, and by clicking these arrows, I can change the thickness of the layers. So I'm going to make them 1% less, 2% less, 3% less. And as I go further down, you can see a couple of things happening. You can see the red curve here is the interactor curve. It's moving shorter with the shorter or the thinner layer thicknesses of this design. But we can also see the original design where I've pasted in that data is around the outside. Now we can see those two colors side by side. And we can see how it changes. See how this now is going orange. And that's because this curve is coming up nicely, just right here around 550, 560, 570. It jumps up, and now we're catching all of this orange. If we go back to our color, we can see right here, this is our orange right here. And that's what we're seeing here as it jumps up here. Okay? I'm going to put this back to original. I'm going to select none of these layers. And if I do some process engineering, if I'm implementing a new process, what I would do is run the design, run the process that I've input into the coding machine. And if I think there's a problem, I do some assessment. If the coding doesn't come out quite right, the color doesn't come out quite right, and I look at all the variables, the materials, the deposition rates, oxygen input, and so on and so forth. And if I think I see a problem with a particular material, and I want to assess that, or a particular layer, I can take all the high layers. I've got T here set as a high layer as well. This is a particular design I was working on earlier. But I can move those, just those ones, and see how it affects the coding and how it changes the color. I can compare the color with the design that I just ran, with the lenses that I just took out of the coding chamber, and see what the color looks like, see if it's matching. If it's not, maybe these aren't the ones. Maybe this isn't the material or the layers that I'm having a problem with. It might be just the last layer. You can make the last layer a bit longer and watch how it changes color. See how the curve changes and watch how the color changes. This is really, really handy. This is really, really nice. It comes in very handy when you're trying to implement codings, but not only when you're trying to implement them, but as you run processes and you want to assess any problems that may arise. Okay? And that's the interactor. We can do the same with any of these codings, the red mirror, the green mirror. This is the digital eye strain AR. If I look at the digital eye strain AR, this is the one where we're reflecting a lot of blue light to get rid of these LCD and LED blue light emissions. If I go into the interactor, and I've still got this red mirror here, so I want to clear that. So I've taken it out. So now this is just the blue AR, the digital eye strain AR. And I can pull up my RGB comparator and see that color as well. I can also manipulate this any way I like, longer to see the bluish colors come out. And this is actually a nice example to show. We can see right here around 440, 450, I've got this nice blue color. As I move it forward, we can see the other colors come in. Okay? It's important to look at how colors behave and important to understand color. Now I've got some green, but I've also got a bunch of blue coming in. If I look here, I've got some green and some blue and some violet. And when we start adding those colors up, this is the result of that color. So it's not just a single color that we want to look at, whether it's a single green or a single blue or a single red. It's about how the curve comes out. We've got 26, 27% a green color here, and we've got some blue and some violet coming up to 54, 55% here. And this is the result of those two colors added together. Okay? So I think color is very important, especially when it comes to ophthalmic ARs, ophthalmic coatings, whether you're doing mirrors or whether you're doing precision optics, display technologies, and so on. And keep that in mind when you're developing AR coatings, when you're having AR coatings implemented, and as you have problems with your AR coatings. It's important to see, to assess coatings as you move through the year, as you move from season to season, and so on. I've talked about that before in previous episodes of Coder Tech, how to characterize your coating chamber, how to look at coatings in December as opposed to August, where in December it's cold and cool in your department and dry, and in August it's hot and it's hard to keep the temperature down and it's hard to keep the humidity out, and so on and so forth. So this is a very nice way to look at color. Color is very important, and using FilmStar and the interactor is very, very handy. If you want to find out more about what I do and look at more of my videos, you can go to coderstech.com. If you have any questions or comments, you can email me right down here at Dave Taddeo at coderstech.com. Thanks for watching.